Okay, let's go ahead and take a look at the derivative of trig functions. Now we've already taken a look at the other two transcendental functions, the exponential function and the natural logarithm function. And we've learned how to actually take the derivative and apply the derivatives using calculus methods. So let's go ahead and also extend that to the trig functions now. Now before we actually get into anything, the one thing that we have to be careful of is that we need to make sure that when we're actually using the derivatives of the trig functions to find, say for example, particular values of x, we need to make sure that you're using your radian mode. So be sure that every time that you're using or solving for any kind of trig function that involves a derivative, you're actually using your radian mode. Okay, so let's go ahead and take a look. Now the three trig functions that we're all familiar with is sine, cosine, and tangent. So if we were to go ahead and take the derivative of those, the derivative, nicely enough, for the sine is actually just going to be the cosine. The derivative of the cosine is just going to be the opposite of the sine, or the negative sign. And the derivative of the tangent is just going to be 1 over cosine squared x, which is the same thing as secant squared of x. Okay, so of course those are your parent functions. Okay, now of course what we're going to come across are situations where you're going to have a composite of the cosine of the trig functions and another function, or you could have also the product or the quotient of the trig functions with other functions as well. So let's just jump straight into some examples here as to how we go ahead and apply the derivative of these trig functions to find derivatives of particular functions. So say for example we have y is equal to cosine of 3x minus sine x. So if we were to go ahead and take a look at the derivative, d of y over d of x, then we need to go ahead and take a look at this. Now notice that this is going to be a composition of functions. You have the cosine x, and then you have 3x as being the composite part. So what we need to do then is we need to take the derivative of the cosine 3x. Now the derivative of the cosine 3x is just going to be minus sine of 3x. So that's minus sine of 3x. I need to multiply that by the derivative of 3x, which is times it by 3. And then I have a minus, and then the derivative of the sine is just going to be the cosine of x. Okay, so what I come up with then is negative 3 sine of 3x minus the cosine of x. Okay, let's take a look at the second one. It says y is equal to tangent of 5x. Notice that that again is going to be a composition of two functions. So I know that d of y over d of x, okay, is going to be 1 over the cosine squared of that 5x times it by the derivative of the 5x, which is just going to be 5. So I know that this is going to be equal to 5 divided by the cosine squared of 5x. Now another way that we could write that is just going to be 5 secant squared of x. Okay, let's take a look at the next one. If we wanted to find the derivative of this one here, now notice that this case over here, this is actually going to be 4 sine squared of x. Now sine squared of x means, of course, that you're taking the sine of x and you're squaring it, so we have to use the power rule. So what we have now then is going to be 4 times it by 2 sine of x times it by, oh sorry, I should write it this way. Let's go ahead and write this a little bit differently so we can kind of see how this is looking. Y is equal to 4 times it by the sine of x squared minus 2, minus the cosine of 2x. Okay, that's basically what it looks like. Now, of course, when we want to go ahead and take the derivative, we should be able to just take it straight from there, but this is what it means. So we have d of y over d of x is going to be equal to 4 times it by 2 times it by the sine of x to the first power, that's the power rule, times it by the derivative of the sine of x. Now the derivative of the sine of x was cosine of x. Okay. Minus, now we have the derivative of the cosine of 2x. We said the derivative of the cosine is the minus sine, so that's going to be minus sine of 2x, times it by the derivative of the 2x, which is just 2. Okay, so if we simplify this, we'd come up with 8 sine x cosine x, and that's going to be plus 2 sine of 2x. Okay, and there you go. Can't go any further than that. So let's go ahead and take a look at a couple more difficult examples. Make sure that we can also tackle some of those. And let's go ahead and say that we have, let's say that this is example D. Let's say that we have y is equal to e to the negative x sine of x. Okay, and then let's go ahead and take a look at one more. And let's say that we look at y is equal to cosine cubed of 4x. Okay, so let's take a look at this one here. Now this one here is actually going to be a product rule. And within the product rule, we also have a chain rule here because this is e to the negative x. So we have d of y over d of x is going to be, let's hold this one constant and take the derivative of that. So hold that constant e to the negative x, times it by the derivative of the sine of x, which is cosine of x, plus, now let's go ahead and take the derivative of this. Well, the derivative of e to the negative x is just e to the negative x times it by the derivative of negative x. So that's just going to be negative 1. And then times that by the sine of x because we have to hold that constant. So what we come out with then is e to the negative x cosine x minus e to the negative x sine of x. And we can factor out the e to the negative x. This is just going to be cosine of x minus the sine of x. Okay? So we can come up with that derivative there. So let's take a look at the last one. This last one is going to be d of y over d of x. Now hopefully you can see that this is the same thing as the cosine of 4x raised to the third power, which means that we actually have the chain rule applied twice because we have the power rule plus we also have the cosine of 4x. So what we can do then is we say, okay, if we look at this, this is the power rule first. So this is going to be 3 times the cosine squared of 4x times it by the cosine of 4x. The derivative of the cosine of 4x is actually going to be the negative sine of 4x. So the negative sine of 4x times it by the derivative of 4x, which is going to be 4. Okay, now if that was a little bit tricky to see, let's go ahead and take a look at it this way then. This is the same thing again as the cosine of 4x raised to the third power. So that's why we did the power rule first, right? Power rule first. And if I wanted to write this one maybe slightly in a different way so that it's a little bit easier to see how we're actually calculating this derivative. Like that. And then we need to take the derivative of the cosine of 4x, which is the negative sine of 4x, then times it by the derivative of 4x, which is 4. So what we come out with then, this is going to be a negative 4 times it by 3, so that's going to be negative 12. This is going to be the cosine squared of 4x sine of 4x. Okay, and there you go. So that one's a little bit tricky because you actually have to perform the chain rule twice. Okay. And there you go. That's how you go ahead and take the derivative of the trig functions. There's another part of this chapter, this section here, that also goes a little bit further into some of the applications. But if you know how to go about taking the derivative of the trig functions, then you should have no problem also in solving some of those application problems as well. Okay, so give it your best shot. We'll see how you do with the derivatives of trig functions. Okay, see you next time. Bye.